In this video, we will work on this problem. This is from 2021 Advanced Paper 1. So let us look at the thought process. Read the problem carefully and visualize what is happening. Identify the keywords, right? So in this problem, you have a circular shaped body, and at the center of the body, you are applying a force F, right? And because of that, the body is moving this way, right? And it is also rolling, right? And the problem says you have enough friction, so there is no slipping, and that is very important. Rolls without slipping, right? So here at this point, no slipping, right? No slip, very important. The goal is to read each option and check whether that is correct or not. So before you jump into solving, see if there is a connection, if there is a pattern, and you will see that options A, B and D, they are about acceleration, and option C is about friction force. So now see, when you have about acceleration, right? So use Newton's law, right? So you have force F applied at the center, you have weight of the body at the center, you have normal force from the ground, and you have friction force, right? And that friction force will be between 0 and there is a max value of friction force, that is mu n, right? Now you write F equal to ma in horizontal direction, so F minus friction equal to ma. A is the acceleration, this A here is the acceleration to the right at the center of mass. Then you write F equal to ma in vertical direction, and you will see n equal to mg because there is no acceleration, in the y direction, right? In the y direction. So normal force equal to weight. Then you write tau equal to I alpha about center of mass, right? And if you write it about center of mass, you have only one torque created by friction, and Fr equal to I alpha. Now the very important thing is that there is no slipping, so A equal to R alpha. This is rolling without slipping equation. So A equal to R alpha. Alpha is angular acceleration. Next, first part, it says for the same value of force, the value of A, right, at the center, the value of A does not depend on whether the cylinder is solid or hollow, right? So solid and this is solid cylinder, right? Solid and hollow cylinder, right? So what you do, mathematically think about, if you can get an equation that has only F and A as variables and everything else is constant, then you can verify if that is true or not. So look at from equation 1, F minus friction equal to ma, and friction you can write as I alpha by R. So, and then alpha you can write A by R, so you get this equation, F equal to m plus I by R square A. And now here, m is constant, R is constant, I is constant for a given body. For a solid cylinder, I is half mr square, and for a hollow cylinder, it is mr square. So as you can see, if it is hollow or solid, it will be different. So the A is wrong, right? A is wrong, right? F depends on whether the cylinder is solid or hollow. Next, for a thin walled hollow cylinder, A equal to F by 2m. So in the same equation, you just put I equal to, right, mr square for hollow cylinder, and you will get A equal to F by 2m. So this is correct. Then here, for a solid cylinder, the maximum possible value of A is 2 mu g, right? So now here you have to think about how the friction force is not constant. It is between 0 and a max value, right? So from this equation, A, right, A is maximum value can be R alpha max, angular acceleration max, and from here you get alpha is Fr by I, right? and F is the friction force. So the maximum value of friction force will decide what is alpha max, and that will decide A max. And maximum value of friction is mu into N, which is mu Ng. So you will get A max is 2 mu G. So B is also correct, and D is also correct, and A is wrong, right? And in this one here, the last option C, the magnitude of the friction force on the object due to the ground is always mu mg, which we already established that friction will be between 0 and mu n, right? So that C is also wrong. Now understand something, that because of this friction, the maximum limit on friction, right? If you keep increasing the F beyond the limit, it cannot be rolling without slipping. It will start slipping.